welcome back. Sorry. So what we have here is a review. First thing, reviewing. Codominance and incomplete dominance. You have to look at notation. You have to look for 3 variations of phenotypes. You still only have 2 alleles, which is why I bring this up. With multiple alleles, the third concept of today, it's when you have more than 2 alleles for one gene. Codominance had 2. It was like the red and the white. When they mixed, they got roan, which was a third phenotype, but roan wasn't a specific genotype. You still only had 2 alleles. Incomplete dominance, when you had the red and the white, they mixed for pink. Pink was not an allele, so it's not that they had more than 2 alleles. Multiple alleles has more than 2 alleles. The premier example for multiple alleles deals with blood typing. And I'm sure that you have some background knowledge of blood typing, which is why this makes it a little more interesting. Hopefully you know, and maybe you can ask your family if they know what blood types they are. Notice there are 4 different phenotypes for blood. A, B, AB, and O. And I know some of you will talk about positive and negative. We'll get to that, but we're just going to talk about the letter situation first. So how does it become these 4 different phenotypes? There are actually 3 different alleles for blood typing in the human body. If you look at the notation, look at how A and B, they both show through. So guess what actually is also included in this phenomenon of blood typing? It's not just multiple alleles, but A and B, they don't blend, so it's not incomplete dominance, but they both show through when you inherit both of those alleles, so therefore it's codominance. So codominance is also working with multiple alleles. If you have A blood, that's the A allele. Notice it has the superscript I is pretty standard, so I wouldn't use I whenever you do codominance on your own. That's why I said in the previous video, don't do X, Y, or I. I is designated for blood typing. The B allele is codominant, so therefore these 2, the notation matches the codominant situation. Notice there's no such thing as AO blood or BO blood. Your blood don't stank. So therefore O is not codominant to A and B. O is actually recessive to both of these, so therefore the notation of the O allele, which is the third 1, 2, 3 multiple alleles, is a little I because it's recessive. So therefore if you paired up this allele with this allele, the dominant B would mask the presence of the O allele, and you wouldn't have even seen the O. It's like you would just have B. So A blood has 2 variations. You can be homozygous A, which says that you have 2 of the same alleles, the I raised to the A, I raised to the A, or you can be heterozygous A blood, which is A with the superscript paired with the O allele. Because the O is recessive, this masks the presence, and therefore you still exhibit the same phenotype. Both of these 2 would have red blood that would be classified as A blood. B is in the same boat as this. You could be homozygous B, or you can be heterozygous B. AB is the combination of 2 alleles. There's only one combination that you can get to have AB blood. That's if you inherit both the A allele and the B allele. As is the case with the O blood. The only way you can have O, which is the recessive phenotype, is if you inherit the recessive allele twice. So therefore, that is going to be the full combination. There's no other combination out there. But that gives you 1, 2, 3 different alleles to match up in any which way to give you 4 variations of blood type. Alright? So I want to do one example of blood typing crosses, and then that will give you enough information to really work with in class some examples. If you had someone that had heterozygous A blood, they tell you that. There's the genotype. If I cross them with someone that has AB blood, notice I don't have to use the word heterozygous or homozygous with that because there's only one variation to give you AB. If I did this, I would separate out my alleles. There's my one parent along the left. Along the top, I'm going to separate these 2. And when I combine them, genotypically, I have 4 unique genotypes. I generally don't ask for genotypic ratios because I really want to focus more on the phenotypes, but I would look here. I've got 2 that are A blood. Even though they have different genotypes, they're both A. So it's 2A. This person has AB blood, so it's to 1AB to 1B. So those are 3 different Punnett squares that you have to do and be able to really work on tomorrow. Review. If you don't understand it, you can look in your textbook, you can look on the internet for different ways, but I will say that not all the time do they notate the same exact way, especially for incomplete dominance. I have seen other ways. Unfortunately, I'll give you those options in class, but I want you to know my specific way for my class because, you know, I want everybody on the same boat at that point. All right. So hopefully you got this, and if you have any questions, I will be happy to answer them tomorrow. All right. See you tomorrow.